Hi. I need that. Thanks for coming. Today, we'll be talking about API design and what's new with Open API. We'll talk a bit about Apigee and how we use Specs, and Google and how we use Specs in our development process. First, a little about me. My name is Marsh Gardner. I'm on the product team at Apigee. I've been at Apigee for over 7 years now, which seems like a lifetime. And now we're part of Google, which is pretty exciting. I generally work on API portals and our Open API tools. I've worked on other parts through my 7 years. And I've been involved with Swagger and Open API in different ways, basically since 2010, I think was my first interaction with Swagger. It wasn't even called Swagger yet, actually. And I'm also a member of the TDC, which is the Technical Developer Community. And I serve as the marketing chair for the group. And I promised I'd take a picture of you all to prove that I actually talked about this today. So you'd say Open API. Excellent, thanks. I'll report that on our Friday meeting. It's a big deal. All right. So we have a lot. I'm going to try to make sure we get through it quickly so there's time for some questions at the end. Roughly speaking, I want to talk about the Open API initiative, why it exists. And then how we use API specs at Google and how we use them at Apigee, and why they matter in the API design lifecycle. And then it's good timing, actually. A week ago, we reached a critical milestone for the next generation of the Open API spec, version 3.0. And so I'll give you a glimpse into what's changing with that and talk about what that stage of the process means. So I think the first half is going to be sort of big picture things, talking about the items 1 to 3, I think, is that? Yeah, and then the last bit will get pretty nerdy about the details of the implementer's draft. So a quick history. Before we had, and I've lost things here, hold on. There we go. Before we had Swagger, we had basically the state of the art was WSDL and Waddle. Those were the ways you could describe services. Really, they were generally HTTP-based services. And then in 2010, a company called WordNick started building some their own tooling that would eventually be called Swagger. And that's part of what made this description format that they'd put into what they were doing exciting. It had authenticity. They were writing, this wasn't a vendor saying, this is the way everyone should describe APIs. This was someone saying, hey, we need to do this. And then over time, as more and more people, they open sourced it, and as more and more people got involved, they had to add things. Like in the beginning, it was just a plain old API key. But APIs, not all APIs just use API keys. So over time, as the community asked for things and they saw this organic adoption and growth, that happened. And then in 2014, so Apigee had been sort of watching this go on. We liked what we saw with Swagger, but it wasn't quite descriptive enough for us. We needed a few things and a few changes to the spec. And so we approached Tony, and WordNick became Reverb at that point. And we asked if they were interested in the next generation. They said yes, so we added a bunch of really cool things to that. And that process took about 6 months to get from the beginning of the working group to the version 2 spec. And then after that, companies shuffled around a bit. And then in 2015, about a year after we started talking about how Swagger could become neutrally governed, maybe under the Linux Foundation, it actually happened. So at the end of 2015, I think it was November, the Open API initiative was officially founded and launched, and SmartBear, who had acquired the assets or the interests for Swagger, contributed the specification. So not the Swagger universe or brand. They broke out the specification and they gave that to the Open API initiative. And then I don't know, within a couple months after that, we began what was the version 3 iteration of the spec. We created a technical developer community, and there were 6 members. I'll talk about that in a bit. But this is really why we started to get excited about things and why it's so important that the spec is neutrally governed. So, and this is just one of several different metrics that all show sort of the same thing. We saw downloads going up. We saw, if you look at Google Trends, you could see similar lines. Basically, so here is where the Swagger 2 spec working group kicked off. That's about when it became the official spec and tooling started to catch up. And then you can see a little further up the graph is when the Open API initiative happened. And then today, we're at the far right, and that's where the version 3 of the spec is. But why did this matter? Why was it so important to put this into some neutral governance model? Well, it was to protect it. The industry needed a standard way to describe APIs, and lots of vendors wanted a way to be able to share these kinds of descriptions, and so it mattered. While that specification was the property of one company, it's too important for one company to have that kind of control. And so putting this into the Open API initiative under the Linux Foundation was really important, and it matters. One of the challenges is that it's hard to not call it Swagger, right? We have a mark that describes this service. It's Open API. And Swagger is a trademark that applies to a brand of tools that SmartBear operates. And they do a great job of that. They have a big community. That's what the specification is known for first. But having the name Open API and using the name Open API is really important. So if you're building support for this into your products, you should use the Open API name. It matters. In the beginning, there were 9 members. 2 of those were Apigee and Google. There were several others as well. But that's in part how it's interesting to me, because that's how I began to meet people at Google, and totally oblivious to the fact that at one point Apigee would become part of Google, and I'd actually work with people like Dan Cerulli. And I think it's pretty exciting that we went from 9 members, and over the time since it launched at the end of 2015, we're now up to 21. And when I made this slide first 2 weeks ago, it was 20, and then it was 21. I had to keep updating it. But I think it's pretty exciting and a great show of support across the industry that we see all of this happening. One of the interesting bits and sort of Open API trivia is that there is a space in the name of the initiative, the Open API Initiative, and so you can see that in the style guide. But the spec actually doesn't have a space, and this is the fun trivia fact you can impress people at parties with, is that we realized a bit too late, after the charter had already been drafted and signed, that it's a lot easier to Google Open API without a space than Open API with a space. But it's a little too late to change the charter, and so we just went with it. It actually has some interesting side benefits. If people use it incorrectly, it's a good sign that they haven't paid attention to the details of the spec. So I think that makes it a feature if you document it, right? So your first takeaway should be that there are lots of ways, however you look at it, where you can say that Open API has emerged as the industry standard. It is the most common way to describe RESTful, I'll put that in quotes, APIs. So moving on, why specs actually matter, because having a specification way to describe, that's great, but without tooling and sort of how that fits into your workflow and makes things better, without that, there's really no point to it. So in order to understand the spec and why it matters, we have to talk about the tooling a bit. So there are many ways in which specs help you in your API lifecycle. I'm going to cover 7 that we've used in our workflows at Apigee at different points along the way. But there are plenty of others. I just picked my favorite 7. So one, just simply having a formal machine-readable interface description or definition, and I'll talk about that at actually in point 7, the distinction between those two. It matters because one, it's language neutral. So maybe you're polyglot. You're building services in lots of different languages, and you need one common way to describe those services. By describing them, and since the format for Open API is YAML or JSON, because YAML is a superset of JSON, it gives you a way to have consistency across teams that really isn't, since everyone has to deal with serializing data anyway, they're all used to that. 2 is that once you can describe it for machines, you can validate it. So now you can make sure that mistakes happen less often. So the ability to validate is really important. But mostly, we used to make like 50-plus page Google Docs, or before that, Word docs, where you describe all this interface, you'd hand it to the engineering team, they'd build something, give it back to you, and maybe it matched. Once you have a machine-readable spec up front, if you do that in the design phase, you can get everybody to drive agreement across teams. Which brings us to point 2, right? So if you're treating that specification in your design phase as the contract, now you can both the client and the server side, we can get people to agree on what actually is being built and why. Because you never get your API design right the first time. You're going to have to change things. And the faster you can do that, the better. I forgot one last key point on this. The machine-readable interface description is ultimately going to mean less work, right? And less work is going to be a theme. You're going to hear that on every one of these, spoiler alert. Every one of these reasons is because it's less work. So having that contract and allowing teams to have discussions about what these services are and how they work, that matters. It ends up you get better APIs and you do less work. You can use those specs to even drive a mock service. So now, instead of waiting for the server team to stand up a version of the API, if you can drive a mock, you can have the client team working in parallel. You can begin to explore how this is actually going to work with the client applications that are deriving value from that API. And so it also means you can learn faster, because now you can validate what you got right or wrong in the design before a line of code has been written. And again, you do less work. You can use that spec to drive client SDK generation or server generation, server-side stubs. This is good because you end up getting more consistent interfaces. When you start treating that spec like code in this way, then you end up getting things that are more likely to agree with the spec that you started with. There are fewer mistakes and less work. You guys can follow along when I do that. I'll give you the cue. Generally speaking, if you're treating your spec as code, then you have it under source control, and you can track changes. This can be really great for instance, your tech writers. If you want your tech writers to be able to keep up with what's changing in the interface, there's a great way. You can just look at the change log, look at the commit history for the spec. So by empowering them, you have fewer mistakes, you've got better documentation, and you've done. Yeah, that's good. You got it. Number 6, you'll do better. You can also make your writers very happy by being able to generate docs, maybe even interactive docs. You can also generate tests from that spec. We did that with some of our node-based applications. If you ever play with Swagger Node, and I'll talk about that in a bit, it actually has something called Swagger test templates that was folded right into that. I think this is a great area of opportunity in tooling, too. I think if you are interested in generating tests from your specs, that there are a bunch of folks out there also looking for a really good solution in that way. So again, you end up with docs that are more accurate. They have fewer mistakes. You can use tests as sort of a check to make sure that what's been delivered is actually what the spec said. And ultimately, it means you do. Oh, very good. What I think gets really interesting is when you use the spec as code as the runtime's contract. So I mentioned a slide or two ago a project called Swagger Node. We started something at Apigee, a project called Apigee 127. It was pretty interesting. What it did is you could define the interface, you design your API interface, and then you would have a loose mapping with the controllers that were the logic. So the problem when you generate code, you're usually getting stubs and you add a bunch of logic into it. If you regenerate the code, you got to figure a way not to clobber that. There are ways to do that. Perfectly good. That's a totally valid workflow. But we wanted to play with the idea that if you could use the interface description as a definition, so the difference being, right, what is truth versus what might be truth. So if you're using it not just as a description, but as the definition of the services, and if you've got a nice coupling to the logic and the controllers, then you can really iterate quickly on your design. You've got, for instance, with Swagger Node. So I didn't explain that part. Apigee 127 became Swagger Node, was contributed to the Swagger universe as an official project, and has the test generation piece in there. Has mocks in it as well. It's a pretty fun way to build APIs. In fact, most of the APIs that I have coded, they don't let me code very often, which is probably good for everybody. But most of the APIs that I do write, I've done in Swagger Node and Apigee 127. And deployed. I tend to deploy them to Apigee because that's my job. Actually, there are 2 other projects I should talk about, though, here. There's a Python-based approach, Python Flask, called Connection that also uses this approach. And then another Swagger project called Swagger Inflector that also has this interesting coupling between the interface and the controllers. So we've used each of those things along the way to make our lives better and do less work at Apigee. But what's been really fun and interesting to me is to have been at Google for the last 3 months. I think I'm still a noogler, technically. And it's been fascinating to see Google's approach. And so even though I didn't plan it for this talk when I proposed the abstract a while ago, we're going to take a little detour and talk about how Google does APIs, because there's some interesting things coming out of that, too, that I think are worth at least talking about. So Google publishes a lot of apps. They've got over 80 on the iOS App Store. I don't know the number on Android. I expect it's bigger. And they've got a lot of APIs. So many APIs, in fact, that they need 14 different categories in order to be able to present them to people. That's a lot of APIs. And the other thing that is just blown my mind about learning about how Google does things is their sense of scale. So this is a data center that's in Mays County, Oklahoma. We're going to have a little data center porn for a few minutes. Indulge me, please. It's kind of fun and cool. This one's in North Carolina. This one's in Belgium. And I've started to think about this as Google builds data centers so you don't have to. I think that you can make a fun joke here about how the internet is just a set of pipes. Well, these pipes, they actually carry water to cool the data center down. And for a sense of scale, to understand how big this is, so that's a Google bike. That's actually how we get the data from one data center to another. We put them on bikes and ride it. Just kidding. We have a lot of computers, and if you try to add up all of the API requests that happen in Google's infrastructure, that's every search query, that's favoriting a YouTube video, it's archiving a Gmail, when you make a wrong turn in Maps, it's your route recalculation. There are probably a bunch of API calls in there, and some of those are just a single API call to Google's infrastructure. That generally results in a ton of calls in the back ends too. So if you start to do some back of the envelope math, it adds up fast because all these computers are talking to each other with APIs. And what that means is that the systems that Google has, they can handle over 10 billion API calls every second. And I remember like 5 years ago when John Musser was talking about the Billionaires Club, like providers who are serving 1 billion API calls in a month, and then multiply that by 10 and do that every second, and that boggles the mind. It's just so big you can't really wrap your head around it. And that turns out to be really important, and I'll come back to that in a second. So Google, I'm going to say about 7 years ago, let's do the math, 7 years ago. Okay, 7 years ago, that started doing its own discovery format. It's a JSON-based format. This was happening about the same time that Swagger was coming out of WordNick. And this was able to drive a bunch of tooling. And they did this, they had to roll their own description format at the time. A lot of you have probably never heard about Google's description format because it was really to solve a Google problem. So they needed it, and I'll explain why in a second, and there was no standard, so they didn't have much choice. So this discovery document, there was a lot of infrastructure based on it. They used it for client generation. A lot of the reasons why I talked about with API specs and why you want them, they were taking advantage of that. So their discovery service drove their Explorer, generated documentation. There were things you couldn't see. They were able to take the JSON-based APIs and map them into their own internal format. And that's where we start. That starts to get really interesting when we talk about scale. That worked. I mean, it solved their problem, but it didn't solve other people's problems. They weren't interested in open sourcing it or formally making that a format for other people to use. It was really to scratch their own itch. And that meant that there was no open source community that sprang up around it. And so, lots of things happening, everything's evolving, and people realize that, so there have been people doing what are called protobufs at Google for at least 10 years, maybe at least a dozen years, I think. And that's how Google sends things back and forth, and that's how they describe their data. And it takes advantage of things like HTTP2 and bidirectional streaming. And so Google introduced Google was using all this internally, and the lesson they learned from doing their own discovery format, in part, was that if they really wanted the rest of the world to sort of appreciate and do things the googly way, then they should do their next version. So that service was called Stubby. They should do the next version of Stubby. It's called gRPC, and they should do that in the open. So this was a little weird to me. I get it. It makes a lot of sense, but it's taken me at least, I would say, it's taken me 3 months to even sort of understand how these things start to fit together. So protocol buffers are pretty interesting. They're language neutral, platform neutral. They're extensible. I like to think of them as, so there are 3 things. One, they're a serialization mechanism. 2, they are a kind of interface description language. And 3, they're sort of a methodology. And that methodology is going to sound kind of familiar because we were just talking about that when I was explaining Open API specs at Apigee and how we use them. So protocol buffers, they're a bit like JSON schema. You use them to describe the structure of your data. gRPC gives you this framework. You get a bunch of tooling that comes along with it. And this is what Google uses internally to do all that massive number of APIs that I was talking about earlier. What this all means, if you add it up, is that if Google used Open API instead of gRPC, we'd probably need another data center. And that's hundreds of millions of dollars. That's an expensive thing. Because when we have to send all of that information back and forth across all those computers that we saw those pictures of before, it actually makes sense to go to a binary format over the wire just for efficiency. Not everybody has that problem. Others have started to adopt gRPC too. Netflix talked about this. They took one of their main projects and Ribbon, I think it was, and instead they're now going to be building their solution on top of gRPC. Also interesting and pertinent, March 1st, the Cloud Native Computing Foundation became the parent of gRPC. This wasn't meant to be a googly thing ever. Or just a Google thing ever. This was meant to be to belong somewhere else. And so it's neat and interesting that it's in the Cloud Native Computing Foundation for a reason we'll come to in a sec. So why 2, though? Because Google's involved in both gRPC and an Open API. So, to synthesize some of the things we were talking about in the beginning, you get your things like documentation, your code generation, your API service configuration, all those benefits of embracing the way of the spec. And so we see the industry moving in a direction that fits with how we think things work best. It's so funny to say we actually. But it's also really interesting that both are Linux Foundation projects. We think the Linux Foundation is pretty great, and it makes a great home for both of these things. And we are interested in figuring out over time how we can sort of bring those things together. I think that's sort of, that may be off in the distance a bit. We've been trying to figure out how and to help, at least with the 3.0 evolution of the spec, consider ways in which these things could start to come together over time. But right now they aren't. But Google uses Open API specs in other ways because there's some nice adoption benefits from it. So the new one platform API, so GCPs, the way we manage APIs internally, we used to serve up that description format that I talked about that they created on their own. But now you can actually get an Open API format of that description instead. Kubernetes publishes, people know Kubernetes, so just in case you don't, this will explain a little bit about what Kubernetes is. I'm no expert in this, but the thing that is interesting is that Kubernetes publishes its Open API specs with the Kubernetes server. At Apigee, we use the Open API, because we're part of Google now, I can say this is how Google uses specs. Apigee uses specs. We use it at different points in the lifecycle. We've got a spec editor. You can generate proxies and flows from specs. And API documentation is generated from specs. Cloud endpoints, it's an API gateway, and its configuration can be done with an Open API spec. So you can start to see that Open APIs, we expect the rest of the world to be speaking Open API and not gRPC necessarily. So we've had to live in both of these worlds and figure out how to live in both of them at the same time. So that's a bit about how we deal with specs at Apigee and Google in general and in the world at large. My advice would be, if you think scale is your biggest problem, gRPC might be a good fit for you. it certainly works well for us. And if you're concerned more about adoption, Open API, and there may be some cases where you consider both. That's where we are, actually. And the reason why I say adoption, one, there's just more traction out there in the world with Open API. Two, it has a benefit of being a text-based description format, and generally speaking, it describes text-based responses or serializations, right? So just like when you see a web page, you can view source and see the HTML and the JavaScript and the CSS. You can see what's actually being sent back and forth across the wire. That is just much more approachable. You get more visibility into how the system works. There's sort of less mystery. Whereas if you're dealing with binary, that's a lot. Unless you've got some special tooling to figure out how to unpack that, you're asking developers to make a big leap to sort of understand why. And so I tend to think of this as an adoption benefit, because what I see with our customers all the time is they're trying to figure out how do they deliver value to people, and how do their developers realize that value quickly. And if the format's getting in the way, that could be a problem. But so I don't think it's an easy question to answer. I think there's a lot of interesting stuff to chew into, particularly now that both projects are in the Linux Foundation. We'll see where that goes. But the takeaway is that use specs. All right. I was a little worried, but it's a lot of content, and we're making good time. So this is where we start to get pretty nerdy. So if you want to understand how the evolution of 2.0 is getting to 3.0, there's a lot here, and I'll recommend that all of this is happening in GitHub. And so you can get involved, like file issues, ask questions. So when we hit the implementers milestone last week, really this means that there are very few changes to how the spec works from this point forward. Definitely the focus is on documentation, but we're also at the point that the challenge we have is that there's this chicken and egg problem. People don't care about the spec without the tooling, and the tooling can't spring up around the spec until it hardens enough to be able to build against it, and that's the point where we're at now. So now it's stable enough that you can begin to build against it. We'll see. I'm not sure how long it will take for things to flip and for 2.0 to become the old out of fashion version and 3.0 to pick up. But it's going to happen sometime in the next 6 to 12 months, is my guess. But first, we got to get through the implementers draft phase. We'll cover a bunch of the big changes today. If you remember one thing, the easiest place to get back to is the Open API Initiatives blog we've been talking about and trying to help the community understand what's changing. We have pictures of unicorns and rainbows, so it's got to be good. That's how we get the younger demographic in, too. So a lot of this work has happened with the TDC, so that's the technical developer community. That's me. I'm trapped in an iPhone. And so Tony Tam, who's sort of Swagger's his baby. He's been there for a long time. Ron Rotowski, both those folks were at WordNick and are now at SmartBear. And Ron probably knows the spec as well as anybody, like forwards and backwards. He's where I go when I have questions, too. Daryl Miller from Microsoft, he's been great. And Jason Harmon, who had been at PayPal when he started working on the TDC and is now at Typeform. I spent a lot of quality time on conference calls with these folks. And so the implementers draft, it represents about a year of work by the TDC and the community, because it's not just the TDC saying, it must be like this. It's people filing issues and us figuring out how to reconcile that with what the spec should or shouldn't do. It means that the third generation of the spec is now relatively stable. And as I was saying, we have this chicken and egg problem. The spec has got to be stable enough for tooling, and that's going to start to become cleaner and tighter. And at this point, only blocking issues, like if we discover we made some terrible oversight, that would get fixed. But most of this is going to be documentation and sort of giving people the supporting information they need to be successful. And this has been happening at least until we hit the full release of the candidate. It's still happening in a branch that's called openapi.next. So if you arrive at the GitHub repo and you see version 2, that's because it's still the official version. It is the only released version of the Open API spec. And so 3.0 will replace that eventually. This is a great time to start getting involved, particularly if you are doing tooling. You can get a lot of attention from people in the developer community now. If you were thinking about getting involved in creating tooling on top of Open API, this might be great, particularly open source. This might be a great time to do it. It will also really help the spec become a real thing. So we'll walk through. I think this is the simplest way to understand what's happened between 2 to 3. So this is just a visual representation of sort of the major high-level sections of the spec, and it's a lot cleaner and simpler on the right. Things like components. So we took a bunch of these reusable definitions that were sort of scattered throughout, and we brought them together under one thing called components. Obviously, the spec is now 3.0. That's exciting, but it's not just that. Like we have introduced semantic versioning as well with the spec. So this, whereas before it was just 2.0, now it's actually we're trying to follow a semantic versioning approach. So clean up at the top level, and in general, and I'll try to point this out as we go through some of these. We reconsidered some of the names along the way. So host is a good example, and we'll talk about that in a sec. We now use host as security instead. I think that's all the stuff I have on this one. Also, we're going to start with some of the easy things to warm up with. It used to be you could use description fields. You could give markdown. And we had, in the 2.0 spec, said GitHub flavored. It just sort of made sense that it was on GitHub and it was easy to deal with. But GitHub flavored markdown didn't have a spec. And so Apiary and API Blueprint also moved from GitHub flavored markdown to common mark because there's a spec. Also, I think specs, leveraging other specs where we can, like URI templates. You will see this come up over and over again. I think we did a great job. Daryl's been particularly good at bringing specs that exist in the real world so that we don't reinvent things. Also, another small change is that we moved from YAML 1.1 to YAML 1.2. In the info object, there's a breaking change. The terms of service is now a URL. And it's something that often catches people by surprise. This version here is not the version of the spec, or it's not the document, the spec document itself. This describes the API. That's the version of the API. This came up a lot. Multiple servers. So now you can actually declare a bunch of different servers. This can be a little tricky, right? Because sometimes if you're dealing with a staging environment, it may be that it's not the same specification, right? You're introducing a new API, and so I would say be a little bit careful here. But if you have a situation where you're running multiple servers, then this starts to make sense. It makes even more sense when you add in parameterization. So now, for instance, if your host name changes based on some pattern, there's a template that lets you do that. And some variables you can leverage to enable that. One thing one word of warning here is that one of the, I think, trickiest things of all in the 2.0 spec was how we use the word default. So we use default to describe parameter values that if the client didn't supply a parameter value, that's what the server was going to substitute for it. Okay, that was that's what the server's initialization would be. Here, however, if you don't have a username, this URL isn't going to resolve, right? So this isn't simply, what the server will do if you don't supply anything. In this case, the default means something a tiny bit different, and that, we probably talked for 15 minutes about whether we should call it something else. We couldn't come up with a better name. These things are hard, and that sort of exemplifies what these conversations. We can have an hour and a half conversation about webhooks and whether or not they deserve to be part of the specification. Some of these we recorded them all. Some of them are really boring, talking about things like that. But fun and passionate. A bunch of people who are really interested in what's the right way to describe APIs. I mentioned the reusable components before, so we collected a bunch of things and added a few more. So one thing to remember is that all of these components require some sort of a reference. We use JSON pointers for that. We also introduced in the components some restrictions around the name. I think there was no character restriction on the names before. That introduced all kinds of bugs. People would come up and try to put Unicode in their definition name. That's a bad idea, so we decided it's probably just good, but it's easier to be restrictive early and expand it later if there's need. If you do want to sort of namespace your components, we recommend using a dot notation. That's one of the accepted characters. Another thing that came up surprisingly often with 2.0 was why can't we add a description to the resource, to the path? And why not? It's a good idea. It makes sense. It should belong there. Another thing you can do here is you can override servers now at the path level. And we introduced support for trace because, hey, it's an HTTP verb and we should do that. We made an effort to do a better job with the URI template spec and keeping that compatible. These schemas for parameters can be done with are basically primitive types. One thing you'll notice is that the form body isn't here anymore. It used to be that you would have to say of a parameter that you'd have to give its location as in body, and you'll see how we can deal with that better now. So the request and content body, this is what replaced that. You can now describe form data using schema definitions. That's kind of interesting. You'll notice the content block here. And there are now media types. So you can describe different media types, and they can have different examples in different schemas. That's a big deal. We can only have, I think, one example per operation in 2.0. I might not have that exactly right. But now you can define any number of media types. That's cool and interesting. It ends up replacing produces and consumes, which I had always found a little tricky in how Open API and Swagger before it had tried to describe these things. So I think it's a much cleaner, nicer way of doing it. Similarly for responses, you've got multiple content types, and you can now wildcard status codes, which is kind of cool. And there was an amusing conversation about how many X's we should allow in status codes. I should probably have written down what video we did that in because it was funny. What call that was. Another interesting piece is that, what is a callback and a webhook if not really just another kind of API? It's more like a push API in that case. And one really important piece of this is to be able to refer back into what you're getting back. So you'll notice the request body URL. That's something that you're looking for in the response. And that's interesting. I definitely recommend looking at the callbacks objects. Daryl Miller did a bunch of work describing that. It's good if you're struggling with also describing your webhooks. This could be interesting to you. We also tried to be more accommodating of Hypermedia, not necessarily as the engine of application state, but it just realizing that Hypermedia is used a lot to point at different things. We wanted to be able to do a better job supporting that. And so now it's possible to use these links to connect operations from responses. And that operation can either be an ID or it actually can be a full href. And this, to some degree, means that documentation is no longer flat because you start to be able to interconnect these operations, and that's kind of cool and interesting. So if that strikes you, definitely check that out in the Open API Next spec. We didn't change a lot to security definitions, but we did one thing that was really important. The flows that we had in 2.0 didn't follow the Open API, the OAuth 2 spec, and so as a general hygiene and cleanup, we fixed that. So that's good. I mean, I don't know how we missed that in 2.0, but I'm pleased to say that that's right now. JSON schema is the thing that gets everybody excited. I don't know why exactly, but I think it was in part because 2.0 had such restrictions around what you were allowed to do when you were describing things, and that didn't fit a lot of the APIs that are out there in the real world. So now you can use, and there are a bunch of caveats. You should definitely read into this carefully in the spec. But I am no expert in JSON schema. I would recommend if you are, check that out. But you are now able to use all of and one of and any of and some of the other interesting pieces that JSON schema allows. It's not full JSON schema support, but it's a whole lot closer than it was. This is good, and it's helpful also to take advantage of all the great JSON tools that are out there in the world. And so in a quick summary, I want to make sure we have enough time for questions. Really what's happened with the 3.0 spec is it's gotten better organized. It has better names. It is, in fact, more descriptive, so it can describe a wider range of APIs. It has callback support in it, which I think is fun, and the ability to use links to connect operations and describe some of these sequences, and then just sort of general cleanup. If you want to get involved, there's a bunch. I mentioned this at the beginning, but we blogged about a lot of the changes that were coming along the way, and then summarized those. Ron Rotowski did a couple of great blog posts recently about this too. Daryl Miller was a big help in this as well. And so, check out openapis.org. You can follow Open API Spec on Twitter. We generally try to be proactive about when we're having meetups and things like that. Actually, there's a meetup tomorrow night, I think, in San Francisco, if you're interested. And then, like I said, all of this is happening on the Open API branch. You can find two projects. Sorry, the Open API GitHub. You will find 2 projects there. One's the style guide. So if you were looking for guidance on how to refer to Open API, either the spec or the initiative, or get the logos, all of our source logos are there with guidance on how to use them. So third takeaway is that the Open API version 3, it's a big step forward. It's generally an improvement. Ken Lane did a nice blog post recently on how pleased he was with the evolution of this. That's exciting too, because he just joined the API initiative. He's now on the governing board. This is a great opportunity for tooling authors, so I would recommend kicking the tires, see if the Open API 3 spec serves your needs, or if you see tooling that needs to exist, like right now, one of the next things we have to do is to actually update the JSON schema that describes the specs so we can validate specs. That's the stage we're at, and we definitely need and will appreciate help, even if it's just commentary on things you liked or didn't like about the changes that have been made.